Hello guys, welcome to my channel. This is Java Data Structures and Algorithms course. Today's tutorial is about implementation of Java sorted set using a linked list and generic programming. Using generic programming, we can create objects of this sorted set with any other class. For example, string, double, long, or any custom class. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Introduction of set data structure. Set is a linear data structure. Set stores unique elements of the same data type. Set can be implemented using an array or a linked list. Array can be fixed array size, or we can use a dynamic array that will grow its size or resize it itself whenever it requires more memory. Sorted set maintains ascending order of its elements. All the elements must be unique and they are in ascending order. Set contains special functions. For example, union, intersection, difference of sets, complement of a set, disjoint sets, and proper subsets. These functions are not available in other data structures, so these are special for the sets. What is generic programming? Java included support for writing generic classes from Java to SE 5.0 or JDK 1.5 version. The generic framework allows us to define a class in terms of a set of parameters that can be used as a type of declared variables, parameters, and return types. Before Java SE5, generic programming was heavily dependent upon the Java's object class. Object is the Java's most higher level parent class. Every class, every internal class or external class extends this class. So they used to box their classes or objects within the object class. That is the root of the hierarchy in Java programming language. For example, using generic programming, we can define classes like this: public class, my class, and this is parameter between the angle brackets. And we can replace this T with any other class, internal or a custom class. This is called generic class, and that can be instantiated with any class type such as integer, string, and double. By using generic programming, we can create instances of a class, of a generic class with any other data type. For example, custom class or an internal class. Time complexity. Insertion. Because set can be implemented using different data structures behind the scenes. So if we implement array based data structure, so it will have a best case O1, and if O1 happens if the set is empty. Then we have average and worst case scenario. Linked list based set has O1 when the set is empty, On when the insertion is carried out at the end of the set. So we have to navigate to the end of the set and insert the new element. We can achieve O1 runtime for insertion at the end if we add another instance field to keep track of the tail node within the set. So we can use that tail node and insert instantly at the end of the set, and we can achieve O1 runtime. It all depends on the design pattern that you will adopt to implement the set. In the case of insertion into a sorted set, the runtime complexity will be O(n) square, because you always have to navigate in the array, locate a location, and then have to shift the elements towards right to make a hole within the array and then insert the new element there. So On is the complexity for the for searching for the correct location, and on again we have to shift the elements, so it will become on square. Runtime for the average and the worst case of insertion within the array, sorted array. In case of sorted linked set, this insertion will be carried out within n time, where n is the number of elements we have to search to locate a correct location to insert the new element. Same way, if we are implementing set using an array, the deletion will be O1 in case the set has single element and removed from the front of the set. Otherwise, if this is not the case, the complexity will be On for average and worst case scenarios, because we have to shift the elements to fill the hole created by removing the elements from the underlying array. In the same case for linked list, if we implement set using a linked list, the runtime is On if the element is removed from the front of the set. In case of average and worst cases, they will happen when we have to search for the element. If element exists somewhere between the linked list, we have to iterate to locate and then remove the element, and its complexity is On. In case of using the additional field tail in the linked list, we can achieve O1 for the removal of an element from the end of the set, because in that case we do not have to iterate or traverse the linked list, that is storing the element behind the scene, and we can directly access the last node and remove it. Search is sequential or linear for unsorted sets, no matter whether we use array based implementation or a linked list based implementation. So runtime is O1 if the first element is the search element or the search key. Otherwise, we have to use On complexity in case of average and worst case scenarios. In sorted array based set implementation, if we are implementing array sorted set using an array, we can utilize binary search, which is way faster than On, and its complexity is O log n. But this binary search is very hard to implement in case of linked list based implementation. So it is only useful if we are utilizing array for the sorted set. Accessing the size of the set is O1 always, because we can directly return the number of elements stored within the set. And print function O1 if there is one element, On otherwise. In best and worst cases, n is the number of elements stored within the set. So print has linear runtime, that is On. Thank you guys, that is all. Let's start the code. And again, if you have not already subscribed the channel, please subscribe. Thank you. Hello guys, I am going to implement generic sorted set that is based on a linked list, and this will be based on Java generic programming. So in generic programming, we can pass or create instances of a class using some template or a parameter. For example, any built-in class or a custom class, that is programmer written class. So there is another requirement in a sorted set. To maintain the order of sorted set nodes, we need to know, or we need to have some functionality or some interface providing some contract or a method to compare the values within the node class. So there are two options in Java. Number one, we can use java.util.comparator interface, or we can also use comparable interface from the java.lang package. So today I am going to use java.lang package comparable. So first we add a parameter to the node class to make it generic class, and this t or this parameter extends the comparable interface. Okay, now this t can be any class that has implemented comparable interface. For example, a string, for example, integer, or any custom class that have implemented or extended the comparable interface and provided the implementation of compare to function so that we can use it to compare the values of the node class. Okay, so as it is, we need some data field private t data and reference to the next node. Okay, in the constructor we pass the data, so we store it and set the next reference to null. Okay, that's it. The other two the getter and setter functions we can generate automatically from the insert code, select getter and setter, select both the fields and generate, and we have both the getter and setter methods for the data fields. That is enough for our class. Okay, now we are going to implement sorted set. The same way we added the template to the node class, we are going to use the same template for the sorted set class. Okay, now this class can be invoked with any class object or class type or parameter or template that has implemented comparable interface. So front of set private node head, count of elements. Okay, now initialize. This dot head is equal to null and this dot count is equal to 0. This is an empty set instantiation. Now basic data structure functions. Basic data structure functions. And here I will implement set special functions. Okay, let's begin with basic functions. Okay, first function public boolean add and t data. Okay, this function will add new element into the sorted set. It maintains two conditions. Number one, order of elements, ascending for example, and number two, no duplication. So uniqueness is a feature of set structure. Data to add and return true if successful, otherwise false. Okay, next we need public boolean add front and t data. Let's make it private. This is a helper function, a utility we can use whenever we need to insert or add an element to the front of the set. Function to add a new element to the front of the sorted set. In both cases, empty set or value is smaller than head node. To add to front, return true if successful or false. Okay, next we need a remove function. Public boolean remove and t data. Function to remove an element from the set if it exists, otherwise return null. Sorry, false. to remove, true if removed, otherwise false. Okay, next we need a function to check if an element exists within the, let's say, find function t data, function to check an element exists in the sorted set. So data to check and return true if exists, otherwise false. We can make it public, we can use it in the testing or other situations. Okay, next, public int size, return this dot count. This will return the number of elements, get the number of elements in the set or size of the set, return number of elements. Okay, next function is public boolean is empty and the return count is equal to 0. Function to check that set sorted set is empty, indicate emptiness of set. Okay, next we need a simple print function, public void print the sorted set. So we need to check if the set is empty, check if empty. If this dot is empty, we notify the user as out this sorted set is empty, and we return from here. Next, iterate the set. So start with no t is equal to current is equal to head, print it. So start with square bracket and using s flag to print the string representation of the data stored in the node. So current dot get data. Okay, copy this. Okay, first move to next node. So current is equal to current dot get next. Okay, now loop and traverse the set while current is not equal to null. So we print, add comma and move to the next node. Don't forget to move ahead, move to next node, otherwise the loop will become infinite loop. Okay, now closing bracket. Okay, that is over print function. Empty function and size function are done. Now let's do the find function. Check if set is empty. So if this dot is empty, return false. Now navigate within the set to find existence of element. So current node is equal to head while current is not equal to null, and if current dot get data dot equals, because we are storing objects within the node class, so we must use equals method. Equals method check the equality of two object instances equals and data. So if we found a match, we return true and navigate. Current is equal to current dot get next and return false, does not exist. Okay, that is our find function. Now the add front function. Create new node. Node is equal to new node and pass data to it. Okay, if empty, set to the or assign to the head. If this dot is empty, so head is equal to new node. Else, in case set is not empty, we set the head to the next node of the new node and assign the head to node to the head. So first next pointer, update next pointer. So node dot set next is equal to current head. Or okay, update the head or make new node the head of the set, so it will become the first element in the set. So head is equal to node. Increase the count and return true. Okay guys, now add function. So add function, we need to take care of two things: add to the front or add to somewhere between the set or at the end of the set. So first thing first, if this dot is empty, if the set is empty or the data stored at the head of the set is bigger than new data is less than this dot head data dot compare to. Here comes the function of comparable interface, because we need to first of all, we do not know the type of data because it is a template parameter. So we know that this template class has a compare to method that we can use to compare two objects. So we are using compare to method from the comparable interface. So data current dot head dot get data is less than 0. It means less than equal to, let's say, if the data, new data going to be stored into the head node is smaller than the data already stored in the head node. So we do add to the front. And we simply, to do that, we simply call this dot add front function. We already wrote this function. Okay, another thing, we need to check the uniqueness. Okay, uniqueness of the elements. So if we call the find function, find and pass data, if this is true, we return false. No duplicate allowed. Okay, now we need to add the and or somewhere between the elements of set. So we create new node new node and pass data to it. Okay, now navigate the set to locate position of new node. So start with node, current is equal to head and move to find the location. Current dot get next is not equal to null, and another condition is the next node is greater than data, sorry, less than equal to data. So current dot get next dot get data dot compare to and data is less than equal to 0. Okay, so it will iterate as long as current is not null, current dot next is not null, and current dot next data is smaller than the new data. So we move current dot get next. Okay, move to find the correct location of new node. Okay, now once this iteration is done and we exit this loop, and there are two conditions. Number one, end of set. If current dot get next is equal to null, it means current is the last node. So we insert at next node to the next to the last node. So current dot set next is equal to node. Okay, the second situation. In the second situation, we are inserting somewhere between the two nodes. So current is not the last node. So we have to update the next pointer or next reference of node to the current node's next pointer. So update next reference of new node. So node dot set next will become current dot get next. Get next. And next we need to update the next reference of the current node. Update next reference of current node. So current dot set next is equal to node. So the node will become the next node of the current node. This is how we insert the new node between two existing nodes. So increase the count, and that's it. And we return true. We can return this from here, return. Okay, because this function is already increasing the count. Okay guys, that is our add function. Now the remove function. Remove function is simple. If set is empty, we return false and do nothing. If this dot is empty, and let's say we print, no, don't need to print, return false, do nothing. Okay, now if it is head node that contains the data, so we remove it. If this dot head dot get data dot equals data, so what we will do, assign the next node to the head node dot get next, and we do nothing else. That is enough here. Okay, next, remove the node from somewhere between the sorted set. Okay, to achieve this, we keep track of two references. So node tree current is equal to head, this is our front of the set, and pre is the previous node from the current. We will keep it to record the previous node while we navigate the set. So let's search current is not equal to null, and if current dot get data dot equals data, if we found a match, traverse the set. Okay, we update the next pointers to remove the current node. So we will do update previous node of current node's next pointer. So pre dot set next will become the current dot get next. Okay, next we reduce the count, or let's break it, break, and here we keep track of previous and next nodes. So pre will become the current node and current node will become the current dot get next. Okay, let's set it to null. Okay, we have removed the node and now we reduce the count. Let's remove it, reduce it here, count, reduce count, count minus minus, and let me change something. It returns boolean, so let's do it here, count minus minus and return true. Now count minus minus and return true. Okay, remove this and we return false here to indicate failure of removal. Okay, that's it. This is our remove function, and we don't need break statement because we are already returning this value to indicate successfully removed. Okay, so guys, basic functions are done. Let's do the set theory functions. Okay, first function, public sorted set union, and sorted set t other. Function will create new set that is the union of two sets. So how we will do this? For example, set A is equal to, let's say, John, Mary, and let's say Jack, Peter. Okay, B is equal to, let's say we have John here and Jack here, and that's it. Let's add one more, let's say Smith. So over A union B will be John comes for one time, then comes Mary. Oh, we need to keep the order. So Jack will come before John. Jack, John, Mary, and Peter. Okay, now order is good. And here again, let's move Jack from here, and we have John and Smith. Okay, the order will be maintained. So first come Jack from A, then come John, and then come Mary, and then come Peter, and then come Smith. It has all the unique elements from both the sets. That is the union of two sets. Okay, other set for union and return union of two sets. Okay, next we need an intersection function. Public sorted set intersection, sorted set T other. Okay, function to create a new set that is the intersection of two sets. So we can copy these to make the new example. Okay, so this is intersection, and we keep same elements here, and we add one element more. Let's say we add Mary. Okay, now we only keep those elements that are common between both the sets. So Jack is not common, John is common, yes, Mary is common, and Smith is not common, Peter is not common. So we have these two common elements to form the intersection of the two sets. Other set for intersection, and return intersection of two sets. Okay, next, public sorted set, let's say difference, sorted set, and other set, function to create new set that is the difference of two sets, let's say A minus B. So let's copy these. Okay, our A set contains these four names and B set contains these names. Okay, now difference A minus B. So A minus B will be a set where all the elements of A comes that are not in B. So Jack is not in B, so we have Jack here. John is there, we skip it. Mary is there, we skip it. And there comes Peter. Peter is in A but not in B, so we will keep it. So that is the difference of A minus B. Same way, if we want to conclude B minus A, it will become John. John is common. Mary is common. And Smith. Smith is the only element that is in B but not in A. So B minus A is Smith. So we will implement this. Then come the public and sorted set complement. So this will create a new set. This function will create new sorted set that is the complement of A. Complement of A is defined as A prime that has all the elements from the universal set, but those elements are not in A. So we need a universal set and we need a set. Okay, let's use this data. Okay, so our universal set is these names. Let's say Smith is also there. Okay, then we have an A set. So A has these three elements: John, Mary, and Smith. So A prime will be Jack, because Jack is not in A, but it is in universal set. John is there, skip it. Mary is there, skip it. Peter is there, okay, but it is not in A, so we will take Peter. And Smith is there, so Smith is also in A, so it will not come here. So the complement of set A is A prime that contains two elements, Jack and Peter. These two elements are in U, but they are not in A. Another condition, another feature of testing: N A plus N A prime is equal to NU. That is the number of elements. Number of elements of A and number of elements of A prime are equal to number of elements of U. So this is how we conclude the complement of a set. Now public Boolean is disjoint. Sorted set other. So function to check that if two given sets are disjoint. So two disjoint sets always have zero elements as common. Other set true if disjoint, otherwise false. So let's say we have A is equal to let's say 1 2 1 3 4 let's say 5, okay, and B is equal to 2 4 and 6. So these two are disjoint because no element is common. So another thing is the intersection of disjoint sets is always an empty set. So next, public Boolean is proper subset. Sorted set T other. In my previous videos, I implemented proper subset function, but I missed one thing to check, that is the equality of two functions, equality of two sets. Because to be a proper subset, there must exist one element in the in one set that is not in the proper subset, because one set is not a proper subset of itself. To be a proper subset, the one set must have an element additional to the all the elements of proper subset. Okay, so today I will implement this feature also. So function to check that a given set is a proper subset of other set. So let's check. First define the sets. A is equal to, let's say 1 2 3 4 5 and 6, and B is equal to 2 3 4, and C is equal to 1 2 3 4 5 and 6. Now B is a proper subset of A because all the elements of B are in A also. And the other condition, the number of elements in A and number of elements in B are not the same. So this is the basic condition of proper subset. C has all the elements of A, but it also has all the elements in B and the number of elements are also same. So C is a subset of A, but it is not the proper subset. Subset but not proper subset. This is subset but also proper subset. So B is not equal to A. Here C is equal to A, and same way A is equal to C. So A is not the proper subset of C. So that was a snag in previous implementation, that I missed this feature. So other set and return true if both if other set is proper subset. Okay, let's implement it. So how we do that? Loop other set and check all elements in current set, and then we'll check it later. So let's start with iteration. So node current is equal to other dot head. Okay, check, we are iterating other set, not the current set. So while current is not equal to null, so if the element is within the current set, we keep iterating. If it is not, if element not common, we return false. If find current dot get data not find, mean does not exist, so it is not a proper subset. Okay, move to next node, get next. Okay, so we reach here, all elements of other set are in current set. Now the condition of equality, if size is equal to other dot size, if both sets have same size, so we return false. It is not proper subset because other is equal to current. Okay, reach here, return true, proper subset. So that is how we will implement both the conditions of checking proper set. Okay, now the disjoint. So we loop current set. If any common element, return false because it is not these are not disjoint sets. So here node current is equal to head while current is not equal to null. So if other dot find current dot get data, so we return false because we have a common element. Return true, these are disjoint sets. Okay guys, this is simple function. Now the complement. Okay, we can copy this data, this code to save the time. So in this set, we iterate the current set, and if the element is not in other set, we add it to the new set. Because we are creating complement set. So create new set, sorted set, so set dot add current dot get data. So basically what we are doing, current is the universal set, so we iterate every element of current set. If that element is not in the other set, so it is entitled to be added into complement set. Return set. Okay, now this is the difference. Let's copy this code and we can use it. Complement and difference is almost the same, except that complement works on universal set, whereas difference works on two sets. Okay, so start with the current set, that is A, and then if the elements of A are not in B, so we add it to the set, and that is it. Okay, the intersection. Use the same code, create new set, loop current set, and find out if the element is common. It exists in the other set, add it to the set. This is the intersection. It is very simple, only take the common elements. And same way, union, create new set, loop the current set, add every element of new set, sorry, every element of current set to the new set, and then loop for the other set, add all the elements, because the add function is already handling duplicates and the sorting order, so we do not need to bother about that, because that is the function of the basic functions of the data structure, to maintain the order and to keep the unique elements. No duplicate is allowed. That is happening within the add function. So in the union and intersection functions, we just process the set theory, and we do not bother about how data structure is working underlying. So loop for the second set is equal to other dot head till the end. Current is not equal to null, and we add it to the set dot add current dot get data. So add function will take care of everything. Current is equal to current dot get next. Okay, I am missing this important line because this can result in infinite loop. Okay, I think I missed it here also, and also here, and also here. These were the infinite loops if we do not navigate to the next node. Okay, and we have here. Okay, that's all, guys. All the functions are done, and let's test the functionality of this linked list, this sorted set. So let's create sets to test the functionality. So sorted set, let's say we're using it with string. Let's say u is the universal set. New sorted set string, and we create two more sets. Let's say set A and then B. Okay, insert elements. Okay, u dot add. Let's say we added John. U dot add Jack. U dot add Peter. U dot add Smith, and u dot add Mary. Okay, now set A. Let's copy these. So A and A and A. Now B, set B. Let's change couple of elements, add another. Let's say we have Smith here and Mary here. Okay, and one element that is not in universal set. Let's say Sean. Okay, let's print these as out universal set u dot print, and let's copy. It will save time. Okay, A set and B set. A and B. Let's run to check if our set is sorted. Okay, so this is our Jack, John, Mary, Peter and Smith. Set A is Jack, John and Peter, John, Mary, Peter, Sean and Smith. Okay, these are our sorted sets. So our set is properly implemented. Let's test set functions. Okay, so first union. So sorted set string set is equal to A dot union B. So S out union of A and B. So set dot print. Let's check. Okay guys, so set A is 3 elements and set B has 5 elements, and John and Peter are common elements. So common elements only occurs once, so it maintains the order and also maintains the uniqueness of the set elements. So Jack is here and John is here only once because it is common between two sets. Mary is in B but not in A, so it comes one time. Peter in both but appears once. That is the feature of set, to have a unique elements. So now intersection. So let's copy this and change the call from union to intersection. Okay, intersection of A and B. Okay, let's print the intersection. Run. Okay, now these two are common elements from the A and B, John and Peter. Okay, next let's do the difference of sets. Okay, let's copy. So set is equal to A difference B. I think I left a typo in the set function. This is disjoint, complement, and difference and intersection. Let's add n. Okay. Okay, the difference of A and B. And next, difference of A and U. Let's say U and A. U and A. Okay, now let's check it. Okay, so difference of A and B. Jack is in A but not in B, so it comes here. Same way U and A. So elements of U and A that are common are skipped. These two elements are not in A, so they came here. Now the complement of sets. Okay, U complement A. U complement A is almost same thing. U difference A, complement of A, that is A prime or A prime, and complement of B. So complement of A is the set that has all the elements of U, but those elements are not in A. Same way, the complement of B is the set that has all the elements from A that are not in B. Okay, let's check it. Okay, this is the complement of A. It is almost same, U minus A, but difference of the two sets exist within any two sets, but complement of a set exists only between universal set and the set itself. Okay, now disjoint sets. So let me add one more set, that is disjoint. Sorted set string, and let's say D is equal to new sorted set, and d dot add is equal to, let's say, Tina, d dot add, and let's say Mira. These two are not in any set, so we can check the disjointness. Okay, if s out, let's say f, is A and B disjoint? So A dot is disjoint B. Same way we print the other sets. So A disjoint D, A disjoint, and B disjoint D. Okay, now let's check it. Okay, let's print new line. Okay, so A and B are not disjoint because they have common element. A and B have two common elements, John and Peter. D has no common element with A, and D has no common element with B. So both these sets are disjoint sets. Now, proper set. Is A proper subset of U. U dot is proper subset A. And B. Okay, let's check it. Okay, new line still missing. Percentage S, percentage D, and okay, run it. Okay, so A is proper subset of U because it has all the elements in U, but U also has additional elements. Okay, next, B is not a proper subset because there is one element in B that is not in A. Okay, now let's check the proper subset. Let's check a subset that is not proper. Okay, for example, we add a new set, sorted set string, let's say E new sorted set, and we add all the elements of A in it. Okay, E, E, and E. Okay, now A and E both have same elements. So let's print it. A dot print and E dot print. Now we check whether they are proper subset. Is A proper subset of E? So yeah, A, and here comes E, and vice versa. A and E. So both should be false because they are same sets. Same sets are not proper subsets. Okay, here they are subsets because they have the same elements, but they are not proper subsets because their number of elements is same. So because basically both the sets are equal. Equal sets are not proper subsets of each other. Thank you guys. That is all for today. This is the implementation of generic sorted link set that is based on linked list. I hope you have learned a lot from this tutorial. And if you have any question, please post a comment. I will reply, I will help, I will guide. And if you have not already subscribed to my channel, please subscribe and promote the content. Have a very good day. and see you in the next tutorial. Thank you guys.